FMS gives flight planning and navigation information, performance calculation and optimization, information display on the MFD, ND and PFD, and predictions for long-term guidance targets. Each of the three FMCS has 5 databases. A navigation database which gives standard navigation data, navaids, waypoints, airports, runways, airways, holding patterns, company routes, terminal area procedures, SID, STAR, approach, MSA, and MORA. Performance database, used for the computation of FMS performance parameters, flight plan predictions and optimization. Variation database, which gives magnetic variation data, used to compute local magnetic variation declination. Pilot Stored Elements database, which stores the waypoints, navaids, runways, and routes created by the flight crew. This database, which contains options and information customizable by airlines. Three FMCs used by the FMS also interface with a lot of peripheral systems via the avionics full duplex AFDX networks, or directly. Two multifunction displays, MFDs. The multifunction display, MFD, displays the FMS textual data, spread out over 50 FMS pages. The MFD is interactive. The flight crew can navigate through the FMS pages, and can consult, enter or modify the data via the KCCU. Crew selects an MFD application, FMS, ATC-COM, SURF, FCU backup, in the MFD menu. General menu includes all accessible pages. Here is the general menu bar of the FMS application. Pages include several panels. Here is the performance page, which contains 6 panels. computes aircraft position and the position accuracy using three types of sources: inertial, others, global positioning system, and radio navigation. The position pages on the MFD display information about the FMS position and position accuracy. In the following slides, we will explain the aircraft position computation for FMS-1. FMS-2 aircraft position computation is identical. Of the three air data inertial reference systems has an inertial reference system. All three IRS positions are sent to both FMS. From these three IRS positions, each FMS computes a weighted average IRS position, referred to as the mix IRS position, to compute the aircraft position. The multimode receiver sends the GPS position to each of the three others. Each others computes a hybrid position composed of the GPS and IRS position, referred to as the GPIRS position. Each FMS uses the on-site GPIRS position to compute FMS position. For example, FMS1 uses GPIRS1, FMS2 uses GPIRS2, GPIRS3 is a backup. Note, the others also sends the GPS position to the FMS, but for display only. FMS computes the radio position, using the data from its on-site radio navigation aids receivers. The FMS can compute two different radio positions, DME-DME or VOR-DME. Each FMS computes its FMS position from its mix IRS position and the GPIRS or radio position, depending on which equipment provides the most accurate data. The FMS uses four main navigation modes that corresponds to the combination of sources that are used to compute the aircraft position. The navigation modes are, in decreasing order of priority, inertial plus GPS, inertial plus DME, DME, inertial plus VOR, DME, inertial only. MES continuously memorizes the difference between the mix IRS and the FMS position. This difference is referred to as the position bias. If the FMS loses our radio and GPIRS positions, the new FMS position will be computed by taking the mix IRS plus the last memorized position bias. FMS continuously computes the estimated position uncertainty. It is used, together with the required navigation performance, to define the aircraft navigation accuracy. The FMS has defaulted RNP values, selected according to the flight phases, and which can be modified by the crew. FMS continuously compares the actual EPU with the current RNP, and defines the navigation accuracy as high if the EPU is less than or equal to the RNP, or low if the EPU is greater than the RNP. If the navigation mode is not IRS GPS, the message, nav accuracy downgraded, appears on the MFD and ND when the navigation accuracy changes from high to low. Aircraft is in GPS primary when the two following conditions are met. The navigation mode is IRS GPS and the navigation accuracy is high. If at least one of the conditions is no longer met, the message, GPS primary lost, appears on the MFD and ND, and a triple click on warning is generated. Note, there is no overall warning during an ILS approach. Reference landing position is the destination runway threshold plus 400 meters on the runway axis. The difference between the IRS position at landing and the reference landing position is the total drift. The average drift is equal to the total drift divided by the time since last alignment. At the end of the flight, each FMC computes an average drift for each IRS position. It is used as a check of IRS performance. FMS automatically tunes the navaids used for the radio position computation, the navaids displayed on the MD, and the navaids of the landing system. Manual tuning always has priority over automatic tuning. In dual and independent FMS mode, each FMS tunes its on-side navaids. On each side, the FMS can tune 1 VOR, 4 DMEs, 1 ILS, MLS, GLS, and 1 ADF. The tuning of the on-side navaids goes through the on-side radio management panel to synchronize the navaids tuning between the FMS and the RMP. If at least one of the RMPs is in nav mode, the FMS tuning of the navaids is interrupted on both sides. The RMP then tunes automatically the navaids previously tuned by the FMS. Note, you will find more information about navaids tuning by RMP in the Auto 34 navigation chapter. An RMP fails, the tuning information is still sent from the FMS to its on-side navaids. Single FMS mode, or in case of communication failure between a FMS and its on-side RMP, the available FMS will tune the navaids of both sides. That are displayed on the MD, and the landing system navaids can also be tuned manually on the position navaids page. Management System, FMS, is to help the flight crew with flight planning. The flight crew enters the flight plan in the FMS. The FMS can simultaneously store 4 flight plans, 1 active and 3 secondaries. The active flight plan is used for lateral and vertical guidance and automatic radio navaid tuning. The secondary flight plans for prediction comparisons. The flight crew can use them to anticipate a diversion, or to store company, ATC, and OIS flight plans. The third secondary flight plan is dedicated to ATC. There are three possible ways to initialize a FMS flight plan: selecting a company route of the navigation database, uplinking a company flight plan from the company ground station, if the option is embedded, or building up the flight plan. Initialization is guided by automatic cursor jump through the appropriate fields: flight number, from to airports, or company route, cruise flight level, cruise temperature, cost index, tropopause altitude and trip wind. The four flight plans are built the same way. The flight plan includes the intended lateral and vertical trajectory. The FMS computes and displays the time, speed, altitude, track and fuel predictions that are related to the flight plan. Primary flight plan includes departure, cruise and arrival. The departure has the following elements: the takeoff runway, an engine at standard instrument departure, EOS ID, the standard instrument departure, SID. The departure transition, trans. The trans is the possible trajectory between the last point of the SID and the first cruise Y point. Cruise part of the flight plan includes all airways and en route Y points. Has the following elements: the arrival transition, trans. It is the possible trajectory between the last cruise Y point and the first Y point of the standard arrival, star. The star. The via. It is the possible trajectory between the last Y point of the star and the first Y point of the approach. Approach and missed approach. The approach part includes the approach, the landing runway and the missed approach procedure at the destination airport. The alternate flight plan has the same elements as the primary flight plan: departure, cruise and arrival. Flight crew makes a flight plan revision. The FMS inserts the changes and displays a temporary flight plan in yellow on the active flight plan page. The function of the temporary flight plan is to allow the flight crew to check a revision before inserting it in the active flight plan, or erasing it. Plan elements are defined by Y points and legs. The FMS automatically orders and links the legs in sequence. A flight plan Y point is sequenced when the aircraft flies over, or near to the Y point. The from Y point of the flight plan is the last sequenced Y point. The to-Y point is the next Y point to be sequenced. The next Y point is the Y point that will be sequenced after the to-Y point. FMS links the flight plan Y points to build flight plan legs. The leg between the from Y point, or present position, pose, and the to-Y point is called the active leg. Note, active leg and to-Y point are displayed white on the MFD. A leg with no termination point is called a manual leg. The flight plan has a discontinuity if no leg is defined between two Y points. Note, for flight plan predictions computation, the system assumes that the aircraft will fly a direct leg between the Y points that define the discontinuity. When reaching a flight plan discontinuity, the nav mode automatically reverts to the heading, track mode. The flight plan from Y point reverts to present position. There are different types of flight plan Y points. Navigation database Y points, inserted by the flight crew as part of a company route, or manually via a lateral flight plan revision. Pseudo Y points, reference points created by the FMS to indicate a vertical flight plan event. Example, speed, top of climb. Flight crew created Y points. Flight crew can create the following Y points: latitude, longitude waypoints, place distance waypoints, place bearing waypoints, place bearing distance waypoints, latitude, longitude crossing waypoints, radial intercept waypoints, circle intercept waypoints, or abeam intercept waypoints. D provides the flight crew with the lateral navigation of the aircraft, according to the flight plan, the navigation database data, Y points, navaids, airports. D can show a primary flight plan, in green, a secondary flight plan, in white, a temporary flight plan, yellow dashed, and an alternate flight plan, blue dashed. The MD shows other FMS data such as cross-track error, which indicates the lateral deviation of the aircraft in nautical miles from the active flight plan. Offset path, which is a parallel path from the original lateral flight plan. In the active or secondary flight plan, the offset path is displayed as a solid line. The initial path is displayed as a dashed line. Only waypoints of the original active path are displayed. No waypoint symbol is linked to the offset path. Note, the offset side and distance are also displayed when an offset trajectory is currently flown or is pending in the temporary flight plan. Approach, which is displayed in blue when at least one missed approach Y point appears on the on-side MFD. The optional engine out SID if the engine failure occurs before the diversion. The EOS ID is displayed as a temporary flight plan, yellow dashed line, until the aircraft sequences the diversion point, or until the EOS ID is inserted, or erased. Y-point information, flight plan Y-point information, for example, constraints, and minimum of route altitude, within 40 nautical mile of the aircraft position. Table containing main FMS symbols. Table containing main pseudo Y-point symbols. The flight plan page displays data, including all flight plan Y-points, in green, and the time, speed and altitude at each Y-point. Note, all data relating to the Y-point are displayed in white. Crew can also display the estimated fuel on board, EFOB, and true wind. Flight plan page displays data, including the track of each flight plan leg and the distance between Y-points. The lateral distance and track predictions are displayed in green. Note, all data relating to the active leg are displayed in white. The flight plan page displays destination airport information, airport identification and runway when selected, estimated time of arrival, ETA, EFOB and distance to the destination along the flight plan. The flight crew can change the flight plan at any time. These changes are called lateral revisions, if the change is made to the lateral part of the trajectory, and vertical revisions, if the change is made to the vertical part of the trajectory. Vertical flight plan uses data to build the vertical profile of a flight plan and to compute altitude, speed and time predictions. Overall flight plan data, cost index, CI, cruise flight level and temperature, fuel and load data, zero fuel weight CG, block fuel, flight phase related data, takeoff profile, climb, cruise, descent and approach speeds and pressure and temperature at destination. Vertical flight plan is computed according to vertical constraints or limits, speed, altitude, time and step climb and step descent. Wind data. When all necessary vertical data is entered, the FMS builds a vertical flight plan with 8 phases: pre-flight, takeoff, climb, cruise, descent, approach, go around, and done. For each flight phase, the FMS computes the optimum speed or Mach profile. The FMS switches automatically from one flight phase to another when the transition conditions are fulfilled. The Y-points indicate a vertical flight plan event. On the MFD flight plan page, they are displayed in brackets. On the MD, lateral and vertical, pseudo Y-points are indicated with dedicated symbols. Speed limit, the point where the aircraft will cross the climb or descent speed limit altitude. Top of climb, the point where the aircraft will reach the cruise altitude, or the step climb altitude, if there is one. Top of descent, the point where the descent is planned to begin. Deceleration point, the point where the aircraft will decelerate for approach and landing. Step climb, the point where the step climb is planned to begin. Step descent, the point where the step descent is planned to begin. Equitime point, an equal time point between two entered reference points. Time marker, the point where the aircraft will be at the entered UTC time. Vertical display, VD, gives a synthetic view of the vertical situation of the aircraft. VD is a secondary mean of navigation. Its main objective is to enhance flight crew awareness of the vertical situation. VD is only available in ARC and ROS nav modes. VD gives the current aircraft position relatively to terrain, safety altitudes, predicted trajectory and weather information. In NAV mode, the vertical cut is defined by the active primary flight plan or the landing system beam when in managed mode. The range represents the area displayed forward the aircraft. It is selected through the MD range selector on the FS control panel. The vertical scale origin is defined by the FMS, such that the aircraft mock-up and most of the trajectory are displayed in the window. Constraints defined in the primary flight plan are always displayed on the VD area. When the altitude constraint is ignored, the same symbols are displayed in white color. Safety altitude is displayed to inform the pilots about the minimum altitude to be flown above the terrain. The safety altitude displayed on the VD area can be either the MORA or the minimum safe altitude, MSA, given by the FMS database. The MSA is only displayed in selected departure or arrival procedures, SID, trans and approach. The MSA and MORA are only for information and do not relieve the pilots to check the safety altitudes on published charts. Note, safety altitudes on the VD area are defined by the FMS. MS computes the safety altitudes that are displayed on the VD inside the vertical cut, along the aircraft trajectory and limited by the VD range. green solid line indicates what the aircraft will fly without any further action from the pilot. Aircraft is in a managed mode and it follows the flight plan or the LS beam, or aircraft is in a vertical selected mode except in one of the glide slope modes, or aircraft is in a vertical selected mode and it respects the auto flight system control panel selected altitude. The green dotted line indicates the FMS predicted trajectory the aircraft would fly if managed vertically. The current vertical trajectory is always limited by a level-off segment when it crosses the auto flight system control panel selected altitude, except in final descent when GS*, GS, FGS star or FGS modes are engaged. When the aircraft does not fit the conditions here above, a flight path arrow is displayed instead of the green solid line. The arrow is oriented function of the current aircraft flight path angle. When the aircraft follows the flight plan, next track change of more than 3 degrees is signaled by a gray area on the VD area. Terrain displayed in this gray zone does not correspond anymore to the terrain located straight ahead of the aircraft. For more information, please refer to A380 Navigation chapter. To the lateral flight plan is called a lateral revision. Lateral revisions are related to a specific Y point or the entire flight plan. The starting point for most lateral revisions is called the revised Y point. Clicking on the revised Y point opens the Y point revisions menu. Entering a lateral revision usually creates a temporary flight plan. Global lateral flight plan revisions are accessed through the Flight Plan Info menu on the Flight Plan page. The flight crew uses the Director Revision to create a leg from the aircraft current position direct to a flight plan Y point, any navigation database Y point, airport, navigate or a latitude longitude, place bearing distance, or place bearing Y point. If the lateral mode is heading track or lock, the nav mode engages automatically when the DIR2 is inserted. The flight crew has 3 additional options to create the direct leg. DIR2 with the beam points, DIR2 with an inbound course or DIR2 with an outbound course. Uses the Insert Next Y Point revision to insert a Y point after the revised Y point. The flight crew can insert a flight plan Y point, any navigation database Y point, airport, or navigate, a latitude longitude, place bearing distance, place bearing, or place distance Y point. Note, if the inserted Y point is already in the flight plan, all legs between the revised Y point and the inserted Y point are deleted. The flight crew uses a delete revision to delete a flight plan Y point or discontinuity. Deletion of a Y point removes the Y point from the flight plan and creates flight plan discontinuity. This discontinuity can be removed using the same delete function. Flight crew uses the offset revision to create a parallel path to the original lateral flight plan. The offset is defined by the start Y point, end Y point, intercept angle, lateral offset distance and offset side. Flight crew uses the hold revision to insert a holding pattern in the flight plan or changed an already existing holding pattern. The FMS has three types of holding patterns, based on three different ways to exit the hold. Hold to fix, HF, hold to altitude, HA, and hold with manual termination, HM. The predicted speed in the holding pattern can be the ICAO hold speed limit or max endurance speed if in managed mode. Note, HM may be part of an arrival procedure, or can be created by the flight crew at any waypoint of the flight plan. F and HA are part of navigation database departure or arrival procedures and cannot be created separately by the flight crew. The flight crew can remove the holding pattern from the flight plan by deleting the holding fix. The aircraft flies the holding pattern until the flight crew decides to exit. The flight crew can insert an HM at present position, immediate hold, or at any waypoint. Database or computed HM can be modified. Flight crew can exit holding at any time by clicking on Immediate Exit in the Active Flight Plan page. Flight crew uses the Airways revision to insert airway segments in the flight plan. Each airway segment is defined by the Start Waypoint, Airway, and End Waypoint. The flight crew uses the overfly revision to ensure that the aircraft flies over a specific flight plan waypoint. When an overfly is defined at a waypoint, the flight crew can remove it with the Delete Overfly revision, Delete Overfly. Note, the related item in the revision list is either Delete Overfly or Overfly, depending on whether the revised waypoint has an overfly or not. Crew can use the Enable Alternate Revision to initiate a diversion using the existing alternate flight plan. Enabling the alternate flight plan deletes all waypoints of the primary flight plan beyond the revised waypoint, including the destination airport and the missed approach. The flight crew will have to intercept the alternate flight plan. Flight crew uses the new destination revision to define a new destination for the primary flight plan. Insertion of a new destination deletes all waypoints on the flight plan between the revised waypoint and the new destination, and inserts a flight plan discontinuity. Departure revision can only be selected from departure airport, first line of the F-plane. The flight crew uses this revision to insert or change the following three elements of the departure procedure: the takeoff runway, the SID, and the trans. Arrival can only be selected from the destination airport. The flight crew uses the arrival revision to insert or change the following five elements of the arrival procedure: runway, approach, including the related missed approach, via, star, and trans. Flight crew uses the alternate revision to insert, change, or remove the alternate airport associated to the destination airport. The navigation database may have a list of alternate airports, maximum 6, and related alternate company routes. If the navigation database has no company route between the given primary and alternate airport, the alternate route will be a direct route, indicated by flight plan discontinuity between the primary and alternate airports. Flight crew uses the fix info revision to compute the intersection of the flight plan with a radial from a specified reference point, a circle with a specified reference point as sender. Note, the FMS computes only for the first intersection on the flight plan ahead the aircraft. The beam line from a specified reference point. The FMS computes the following predictions for each intersection: time of arrival, distance from P-Pros and altitude. The flight crew can insert the computed intersections into the flight plan. Flight crew uses the latitude-longitude crossing revision to insert a series of Y-points along the flight plan. The flight crew defines the Y-points by entering the start Y-point, origin latitude or longitude, latitude or longitude increment, and maximum number of interceptions. Flight crew can do lateral revisions on the MD by clicking on the aircraft symbol, a Y point, or the destination. Crew uses the closest airport's revision to view the 4 nearest airports from the current aircraft position. For each airport, the following information is displayed: distance, bearing, time UTC, FOB, and effective wind, if computable. The flight crew uses the equi-time point revision to insert a pseudo Y-point computed between 2 reference points. The created equi-time point will be inserted along the flight plan. The flight crew uses the time marker revision to create up to 4 time markers. The created pseudo Y-point will be inserted along the flight plan at defined time. The flight crew defines the Y-points by entering the time UTC or a remaining time. Plan is called a vertical revision. At a revised Y-point, the flight crew can access the vertical revisions on the flight plan page by clicking on the time, speed, altitude, wind, or accessing the Y-point revisions menu. The flight crew uses the time constraint revision to enter, change, or delete a required time of arrival, RTA, at the waypoint. There can be only one RTA per flight plan. If the flight crew inserts an RTA where one is already inserted, the previous one will be deleted. Estimated takeoff time, ETT, is the time reference used for the flight plan predictions and pre-flight. The ETT is a flight's crew entry or an FMS computed time based on an RTA which has been inserted in the flight plan. Note, the flight's crew entry has priority over the computed time. Crew uses a speed constraint revision to enter, change, or delete a speed constraint at a waypoint. The aircraft will fly at the specified speed and climb from the present position to the revised waypoint or, in descent, from the revised waypoint to the destination. The speed constraint may be a flight crew entry or a database value. Note, a speed constraint cannot be modified in the active phase. The flight crew uses a speed limit revision to enter, change, or delete the climb or descent speed limit at or below a specified altitude. Only one speed limit can only be defined for climbing or for descent. The speed limit may be a flight crew entry or a database value. The FMS default value is 250 knots at 10,000 feet. Flight crew uses the constant Mach segment (CMS) revision to insert a Mach constraint on a cruise segment of the primary flight plan. The CMS is defined by the start waypoint, Mach number, and end waypoint. The existing CMS can be modified or deleted. The flight crew uses the altitude constraint revision to enter, change, or delete an altitude constraint at a waypoint. The altitude constraint may be entered by the flight crew or is a part of the database. Window between two specified altitudes is only part of the database and cannot be modified by the crew. The flight crew uses the step altitudes revision to insert or change a step climb or a step descent. The flight crew defines the step by entering the step altitude and step start waypoint. As soon as an altitude is inserted, the FMS computes an optimum step point with fuel and time savings compared to the step climb at the entered waypoint. A click on the select key will insert the optimum step point in the temporary flight plan. The flight crew defines the step by entering the step altitude and step start waypoint. The FMS does not compute an optimum step point for a step descent. Data is used to compute reliable predictions and performance. The History 1 panel gives an access to the wind data recorded during the previous descent. The flight crew uses the wind revision to enter or review wind data for the climb, cruise, and descent phases. is to show you selected and managed modes through the 8 flight phases. Taxi, climb and nav modes are armed. When the aircraft enters the lock beam, the runway mode arms automatically, provided an ILS is available. Takeoff mode combines the vertical mode of the speed reference system with the lateral mode. SRS automatically engages when the thrust levers are set to TOGA or MCT flex détente, provided V2 is inserted on the takeoff panel of the FMS performance page, and slats are extended. SRS controls the speed via the elevators. SRS is a managed vertical mode. Way mode gives lateral guidance during the takeoff roll and initial climb, up to 30 feet if a lock signal is available. Runway is a managed lateral mode. If nav was neither armed nor engaged, runway track mode will engage at 50 feet radio altimeter. The runway track mode guides the aircraft along a constant track target, which is the aircraft track at runway track engagement. Runway track mode will disengage when the crew pulls the heading track knob. SRS mode. The aircraft maintains speed equal to a minimum of V2 plus 10 with all engines operative. Note: the speed target remains at V2. If the FMS detects one engine failure, the speed target becomes the highest between V2 and current speed limited to V2 plus 15. The nav mode will automatically engage at 30 feet radio altimeter if a flight plan has been inserted. The nav mode is a managed lateral mode that guides the aircraft laterally along the FMS flight plan. Production altitude. Lever climb flashes, requiring the crew to move the thrust levers to the climb détente. Auto thrust is now active, and thrust climb is displayed on the FMA. The acceleration altitude. Climb mode engages automatically, provided the lateral nav mode is engaged and the auto flight system control panel selected altitude is above the current altitude. Note: open climb engages if a selected lateral mode, for example, heading, is engaged. Climb mode is a managed vertical mode. Climb guides the aircraft vertically along the FMS flight plan to the auto flight system control panel selected altitude or to the next altitude constraint, whichever comes first. Therefore, altitude constraints associated with applicable waypoints are taken into account in this mode. Note: in open climb, all constraints are disregarded. When an altitude constraint is defined at a waypoint, thrust climb remains engaged until reaching the altitude constraint. Climb mode automatically re-engages when sequencing the waypoint associated with the altitude constraint. The modes are always related to one altitude mode. Then the aircraft reaches the cruise flight level set in the FMS performance page. The autopilot in our flight director vertical mode becomes alt cruise. Cruise, the aircraft will maintain the econ speed or any other speed selected on the auto flight system control panel by the crew. Descent mode engages as soon as the pilot pulls the alt knob of the auto flight system control panel, provided a lower altitude has been selected. Open descent is a vertical selected mode. Descent is engaged. The autopilot in our flight director adjusts the pitch in order to maintain a speed Mach target, selected or managed. The auto thrust then maintains idle thrust. All the altitude constraints are disregarded. Descent mode engages as soon as the pilot pushes on the alt knob of the auto flight system control panel, provided a lower altitude is selected on the auto flight system control panel, and nav mode is available. Descent mode of the autopilot in our flight director guides the aircraft along the FMS descent path. Descent is a vertical managed mode. All the altitude constraints associated with waypoints will be respected. In descent mode, when the speed is managed, a target speed range indicates to the pilot the acceptable speed variations required to maintain the descent path. A vertical deviation symbol is displayed on the altitude scale, with a digital value provided on the descent panel of the FMS performance page. Vertical speed and flight path angle are vertical selected modes. Vertical speed, flight path angle acquires and holds the vertical speed, or the flight path angle, that is displayed in the vertical speed, flight path angle window of the auto flight system control panel. Push button arms the approach modes according to the type of approach inserted in the FMS flight plan, ILS or NPA, or the ILS frequency course, manually inserted in the radio management panel, or MP. For additional information refer to A380 Communication chapter. ILS approach. When the approach push button is pressed, lock and glide slope arm provided. The ILS and radio altimeter are not faulty, aircraft is above 400 feet, and ILS frequency and course are set identically on both receivers. When the lock is captured, lock star mode engages. Once the aircraft is established on the lock axis, lock mode engages. When the glide slope is captured, glide slope star engages and switches to glide slope mode when the aircraft is established. Glide slope will be captured provided lock star is engaged. At 400 feet radio altimeter, land mode engages. In this mode, all FCU selections are no longer taken into account by the FG. Land mode can only be disengaged by engaging go-around mode. At 60 feet radio altimeter, the flare mode engages. At 30 feet radio altimeter, if the AP is engaged, AP-FD guides the aircraft on the runway center line and provides the required pitch attitude for the flare, and if auto thrust is active, thrust is automatically reduced to idle. A retard callout is triggered at 10 feet. Around mode engages when thrust levers are set to toga and flaps lever is not at 0 detente. Go around combines SRS mode and go around track mode. Both modes engage at the same time but disengage separately. Round engagement. FMS predictions are lost, therefore open climb arms. When the pilot engages nav or heading, SRS remains engaged. At the go-around acceleration altitude, FMS predictions are recovered and climb engages. All cruise or all constraint arms. Function. It allows to fly published non-precision approaches in a way similar to precision approaches. AirNav, GPS, VOR, VORDME, and NDB, NDB-DME. In addition, the function allows the crew to fly a log-type approach with managed vertical guidance, log back course, and ILS with glide slope out. The FLS function is only available for approaches coded in the FMS database. In database stored data, the FMS computes an FLS beam defined by an anchor point, a course, and a slope. Lateral FLOC course corresponds to the final approach leg of database. Vertical FGS slope corresponds to the final approach slope of database. All published non-precision approaches can be flown with FLS function if they are coded in the FMS database. At least one FMS and one MMR are available, and the approach capability is FAPP or FAPP plus rho. Refer to FLS capability. Note, the offset between final approach course and runway course must not exceed 50 degrees. FLOC and FGS beam, the MMR, computes the FLS deviations. They are displayed on the PFD and sent to the prims for flight guidance. FMS borrow altitude is used by the MMR to compute the FGS deviation. It is QNH referenced and computed in respect of the borrow setting. Note, the FLS beam does not take into account terrain obstacle clearance outside of the published approach. Less push button on the FSCP will display FLS course pointer, FGS and FLOC deviations, anchor point, and FLS capability. FLS capability is displayed only in FMS descent and approach phases. For FLOC and FGS interception is identical to the one provided when flying an ILS approach. Approach push button pressed. FLOC and FGS armed. Lateral FLOC star and FLOC when established. Vertical FGS star and FGS when established. Note, FLOC can be armed independently using the lock push button. On the MD, the virtual FLS lock beam is displayed up to 80 nautical mile in plan and arc mode, 160 nautical mile in ROSNAV mode. On the VD, the FGS beam is displayed when FLOC star or nav is active. At the runway threshold, the anchor point is defined as the runway threshold, coded in the database. The anchor point is defined in altitude as being either the threshold crossing height or threshold plus 50 feet if threshold crossing height is not defined. Anchor point is R, W, Y, X, 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 X for runway identification. Example given, runway 32 left. The map is located beyond the runway threshold. The anchor point is a published point, called final end point. It is defined in position by latitude, longitude, and coded in the database. The anchor point is defined in altitude as being either the TCH or threshold plus 50 feet if TCH is not defined. Anchor point is EPXXXXXX for runway identification. Example given, EP32 left. Is located before the runway threshold. The FMS computes a fictitious point that represents the anchor point. Anchor point is EPXXXXXX for runway identification. Example given, EP32 left. The FLS function is not available for some approaches. In this case, the FMS invalidates the FLS function, and no FLS for this approach is displayed in white on the MFD FMS message area. FLS beam is corrected for below azimuth temperature, provided that the temperature is entered on the approach panel of the perf page. Note: FGS based on azimuth is displayed in the MFD FMS message area when the LS push button is pressed and the temperature has not been inserted. The FLS function allows the crew to fly approaches based on the ILS localizer for lateral guidance and FGS for vertical guidance if the approach has been coded in the FMS database. ILS approach with glide slope inoperative. Glide slope must be deselected on the position evades page. Lock approach. Lock back course approach. A managed speed Mach between VLS and Vmax minus 5 knots. Depending on the aircraft's configuration, Vmax is VMO, MMO, VFE, or VLE. phase. When nav mode is lost, for example failure or discontinuity, nav mode reverts to heading mode. A triple or warning sounds, and the FD roll bar flashes for 10 seconds. Note: the reversion is similar in all constrained mode. Climb mode. If nav mode is lost or if the crew engages heading track mode, nav mode reverts to heading track mode, and climb mode reverts to open climb mode. Note: moreover, if nav mode is lost, a triple click or warning sounds, and the FD roll and pitch bars flash for 10 seconds. Send mode. If nav mode is lost or if the crew engages heading track mode, nav mode reverts to heading track mode, and descent mode reverts to current aircraft vertical speed, FPA. Note: moreover, if nav mode is lost, a triple click or warning sounds, and the FD roll and pitch bars flash for 10 seconds. More descent modes revert to the current aircraft vertical speed or FPA when the flight crew sets the auto flight system control panel selected altitude below the aircraft altitude in climb, or the flight crew sets the auto flight system control panel selected altitude above the aircraft altitude in descent. Speed mode engages and all constraints are disregarded. Note: a triple click or warning sounds. The FD pitch bar flashes for 10 seconds. Regards the FD orders, the speed will decrease or increase. When the aircraft reaches VLS or Vmax, the auto thrust automatically reverts to speed mode in order to recover the speed target. The FD bars disappear. Flight auto flight system control panel fault is triggered if a failure on the auto flight system control panel is detected, or both FCU channels are faulty, or the auto flight system bus is faulty. Crew has to use the AFS control panel page of the MFD-FCU backup. Note, the AFSCP backup virtual push button has been automatically activated. The autopilots and flight directors are not disconnected. Case of FS control panel fault, the flight crew has to use the FS control panel page of the MFD-FCU backup. Normal operation. FMCA provides data to FMS1. FMCB provides data to FMS2. FMCC is the standby computer, and the FMS source selector knob is in norm position. To active FMCs, one is the master, the other is the slave. Note, only the master FMC sends long-term guidance to the flight guidance. In normal operation, the two active FMCs independently calculate data, and they exchange, compare, and synchronize this data. FMS1 and FMS2 are in dual mode. Following abnormal operation may occur. No more data exchange between FMS1 and FMS2. The FMSs revert from dual to independent mode. Note, it may be due to a communication failure, avionics network problem between the active FMCs. Active FMC is faulty. The standby FMC synchronizes with the active FMC that is still healthy and replaces the faulty FMC. FMS1 and FMS2 are still operative. Note, during the reconfiguration, the message FMS page restoring, please wait, is displayed on MFD. Cs are faulty, one entire FMS side is lost. The FMS is in single mode. Case, the flight crew uses the FMS switch to display the data from the healthy FMS side on both sides. Here, the PFD, ND and MFD display FMS2 data on both sides. All FMCs are faulty, all FMS data and functions are lost on both sides. FMS1 and FMS2. The flight crew has to tune then evades via the radio management panel and can create a basic flight plan using the integrated standby instrument system.